Starting with important, education is important, and it is because it's at the core of so many social problems that we have experienced in our world, whether they be poverty or war or medicine. Better education can help solve all of these problems. At the same time, this is an area that's really interesting from a scientific perspective. I'm actually very passionate personally about both of these issues because I think it's super interesting, this question of how does human learning work. And, this is a professional master's program, but you'll also learn a lot about what we know and also some of what we don't know about how the mysterious process of human learning works. And then the final super exciting and challenging part is technology innovation, which is not only challenging and fun, but also very powerful in terms of having an impact. Work we've done here at Carnegie Mellon includes intelligent tutors that help urban students catch up in mathematics, and even the very best students get even better. Learning games on mobile applications being used in Africa. Of course, there's lots of recent work with online courses that are massive and open. Some of that work involves virtual laboratories, simulations, educational games, really scaling education. There's also work here that is in the sort of realm of mixed reality or ubiquitous computing. For example, this intelligent exhibit that makes doing science fun for young kids here. There's a Kinect camera watching a kid learn from a scientific experiment on an earthquake table, and getting feedback from the computer system that's basically watching what the kid does. So high-tech possibilities there. Before going a bit more into the Mellon program, I wanted to say a little bit about my background because it in some ways reflects the program and our goals. I come from a reasonably modest educational background, a working-class family in the Midwest of the United States in Wisconsin. I recognized that I had pretty good math and technology skills, but I wanted to apply those skills to make a difference somehow, and that the passion for education was there. I did a math undergraduate, then I started a PhD in computer science and finished with a master's, and I decided that I wanted to understand human learning better, so I switched to cognitive psychology, and at that point I discovered how unique Carnegie Mellon was, and I came here to do a cognitive psychology PhD. Continued to do work in artificial intelligence at that time, and was part of the founding faculty then that created the Human-Computer Interaction Institute, or HCI. My research has involved, among other things, intelligent tutoring systems being applied for mathematics, particularly for disadvantaged students in city schools. In 1998, we spun off a company. We've shown, as I'll illustrate in a moment, that we can really double learning of students because of that. About 10 years ago, we got a lot of funding from the National Science Foundation in the United States to do a big Science of Learning Center, which we called Learn Lab, and we work with lots of different courses and schools and companies as part of that 10-year project. And one of the culminations of that was the idea that we need to get more professionals out in the world who understand learning science and know how to engineer and design through iterative use of data better educational technologies and really more generally better educational approaches of all kinds. So what I'm going to drill down into is what's so special about Carnegie Mellon and the medical program, tell you a little bit about the curriculum, particularly our culminating capstone project, and some of the courses, and then have a slide telling you about some of the nitty-gritties of finances. CMU is really special. We made a big difference by applying real learning science in the real world. Our cognitive tutors, a kind of intelligent tutoring system influenced by cognitive science research, have been in use for the past years by over 500,000 students every year. Those students are not only starting courses, like you see these big numbers with MOOCs sometimes, but in this case, we're talking about students who really finish those courses. A recent huge randomized field trial where 147 schools were either assigned to use cognitive tutor or did what they usually do in algebra courses. showed that over the school year, use of the cognitive computer algebra course, and it really is a full course, not just the technology, it's a blended course. Use of that course doubles students' achievement over the school year. This was also a financial success of our work because the company grew and was sold a number of years ago now for a nice number, and we maintain a research relationship with them. Almost about 10 years ago, we thought that we should be applying this cognitive tutor approach not only to school learning prior to college, but also the college level courses. And a number of faculty here started the Open Learning Initiative. That's what OLI stands for. And there now, this 25 number is wrong. There's more like 30 open online courses that we provide. They're highly interactive, and they're based on learning science research. One of the best illustrations of that is work on one of our statistics courses that was used in one study, another randomized field study, illustrated over here in the blue. We compared a traditional college course where students spend a semester against one that was redesigned based on research, but only ran for half a semester and met essentially half the time. In fact, it was only meeting 2 days a week where the others met 3 days a week, so it was even less than half the time. Nevertheless, students actually learned more, and that's the power of educational technology. You see in this picture how there's really if you will, an ecosystem of all kinds of things going on in the area of learning science and educational technology at CMU. A lot of it started back in the 50s even with Herbert Simon is here. He's the Nobel Prize winner in economics actually, but he's a psychologist as well and was the founder of artificial intelligence. The work he did with Alan Newell illustrated here. They studied how people play chess, and their work was at the core of what today is chess-playing computer programs that can beat the grandmaster of the world in chess. That influence led us about a couple of years ago to label this ecosystem at CMU the Simon Initiative in honor of Herbert Simon, and the kind of work that he did was very relevant to this notion of using theories of learning to improve educational practice, but also using data from fielded educational technologies to drive new theories of learning and work around this cycle in an engineering design process that leads to improvement. It's a fundamental idea in human-computer interaction, which is our primary home. Psychology department here is a major part of it. I mentioned the center, the Learn Lab Center. We have an Everly Center for Teaching Excellence at CMU, led by Marcia Lovett. We have a super machine learning department. We have a Language Technologies Institute. We have an Entertainment Technology Center that does a lot of educational games. A lot of things going on at CMU. And the Metals program is in the middle of all this too, and all of these different centers and departments are contributing to it. Outside of CMU, there's so much going on in this area. Learning and training applications continue to boom. You can look up this report and find out more, but every year there are more new ideas, more new technologies, more new companies, and more new careers. And CMU has been contributing to that in many ways. I guess you're getting some echoing. I'm going to mute the external line so that reduces here.
You are now muted.
For just a moment to pause. Apologies for the echo there. I hope it is better now. The ed tech market, as I said, is huge. Here's some statistics on that in dollars and students. This actually, almost everybody in the world in some ways is a student. On-the-job training continues, and certainly it ought to if it isn't explicitly. The potential is huge. The number of startups we see is amazing. They're happening. We hear about a new one almost every day. CMU's been contributing to that. I already mentioned our Carnegie Learning spinoff. Acrobatic was a spinoff of the Open Learning Initiative that I mentioned earlier. PlayPower Labs and Shell Games are educational game companies, essentially. Lightside is applying language technologies to learning, was recently purchased by Turnitin. XB is another one of these very new companies. This is actually a small list of many such companies. And also through LearnLab, we've been involved with many corporate partners, some of them listed here. If you go to the Metals website, you can actually see a nice blog from one of our important partners, Boris Saxberger, who's the Chief Learning Officer at Kaplan, who has been, along with us, one of the proponents of this idea that we need to design and engineer courses more iteratively, and he has a piece about learning engineering there. So, really, what I want you to take away from this is that Carnegie Mellon is a super special place. It's strive for innovation, for interdisciplinary research. Herb Simon's a great representation of that, but also research that makes a difference in the world, that has an impact. It's cutting edge, it's grounded in theory, but it's connected in industry. And we are also very committed to having interdisciplinary teams work together collaboratively, and that'll be a part of the program here that I'll mention in a moment. Working together collaboratively on projects so that you get practical experience that you learn by doing, an idea that many have promoted, but Herb Simon being one of those folks. So let me say a little bit now about the curriculum, starting with the capstone project that you will be involved with in the Metals program in the spring and summer. The idea in those 2-semester long period is that you're going to work in an interdisciplinary team of about 4 to 6 people. We accept folks that are coming from computer science, psychology, design, education, business, many areas, and we'll team you up with folks that have complementary strengths to yours. And you'll work for real paying industry clients. Some from that list before have been past clients. And we will support you in delivering a super great product to them. And really it's focused more on a high quality product design than anything else. And that'll allow you to integrate your skills. It'll allow you to have a portfolio that'll be powerful for you to get a great job. You'll learn how to write and give presentations, important things for professionalization outside in the world. Just to give you a little bit of a sense in a brief amount of time here, we focus a lot on gathering field data from the product users. They're often students, but sometimes there's professionals involved, and some of the clients we've worked with are doing teacher training, for instance, or teaching better leaders inside of companies using mobile devices. You go out and you interview and collect qualitative data, maybe collect some quantitative data, numbers and quotes and so forth to fuel a design process. You'll also read relevant literature. You'll put it together to build a deep understanding of the needs of the students or the customers. You'll use research to bring it to bear, and we'll work you through an iterative design process that involves, as illustrated here, paper prototypes of interfaces that then get turned into fast computer-based prototypes that through each of these stages you'll test with real student or trainee users. We'll teach design ideation strategies like these storyboards that are actually real products of past student groups, and you'll put all of that together in the project. To prepare you for this project and for your professional experience, we have a lot of great courses, and I want to start first by illustrating one of the courses you would take in the fall called E-Learning Design Principles and Methods. I typically teach this course. Here you would gain a broad understanding of the field of learning science as it applies to e-learning or educational technology development. You'll learn how to apply evidence in theory. You'll also learn how to adapt various methods like cognitive task analysis, like contextual inquiry, to collect both qualitative and quantitative data to make good decisions about designing instruction. One of the key themes here is to get beyond simple-minded views of education that often pit two alternatives to teach as if there is only two ways to teach. Like, you take a back to the basics approach or you emphasize understanding. Is it better to give students more assistance, more help, or is it better to challenge them more? Those are deep issues, but they often get phrased as if there's only two ways to teach, and we get education wars. At least here in the United States, we've had what have been called education wars, where people fight over how we should teach reading and math and science and so forth. But what we want is a deeper dialogue, and one that's even deeper than what's in the current cognitive psychology and educational psychology literature. It's a lot more nuanced and subtle and detailed in that literature, as reflected by some of these other two-way or binary distinctions in the field. What I've italicized and bolded here is what the research consensus seems to be on a number of these issues. But note that some of them have bold and italics on both sides, and in none of these cases do you find that the idea being promoted, the recommendation or principle, it doesn't work every time in every practical application or every research setting. So it really poses a challenging problem. And it's one we've written about. For example, Vincent Olavin is another one of our faculty members, characterized here in this paper a notion of a dilemma between how much assistance and how much challenge. But folks here at CMU have also contributed to this book here. Marcia Lovett was one of the key authors, and others from our Eberly Center. This Organizing Instruction Practice Guide was another document from our Department of Education that I helped to write in 2007. This is the textbook we use in this particular course that you would take in the fall. This diagram is meant to illustrate why thinking there's just two ways to teach is not a good idea. One of the many ways you can vary teaching is how often and how much distance is there between practice opportunities that you give students. And most of what we do in textbooks and in classrooms is what you might call focused or mass practice, where you spend a block of time on just one topic, then you move on to another topic and you spend a block of time on it. But there's a lot of research that says you should really be hitting these topics over and over again with pretty wide spacing in between. Or maybe better yet, adaptively widening the spacing as students get better. That's just one dimension though. Here's another dimension. How many examples do you give students versus how many problems or tests of their knowledge do you give? So now we have 3 choices times 3 choices and 9 possibilities. If we add the question of should the examples be more concrete or abstract, now we've got 27 choices. Should the timing of the feedback we give students when they're learning by doing be immediate? Should it be delayed? Should there be no feedback? Multiply by 3 again. Should we ground topics, group topics together or interleave them? This is somewhat related to the first one, but it is distinct as a matter of fact. Who should be explaining, the instructor or the student or some mix? And we could go on. There's many such dimensions. We've identified at least 30, and there are many more. But if you put all this together, how many different ways are there to teach? There's at least 200 trillion different ways to teach. It is fast. Are we going to get there by figuring out that there's one best path for all situations? It's pretty clear from the research literature that there isn't one best path, that these choices depend on the content that you're teaching. If you're teaching language learning, you're going to find a different optimal path than if you're teaching mathematics, than if you're teaching history and so forth. But also, the choices vary depending on how novice or expert or intermediate is the student population that you're addressing. So you really need a way to guide these choices. They really do depend on you as a designer with the help perhaps of experts, developing a deep understanding of the content in these domains. One technical way of describing that is you need a cognitive model of how students think about the content in these domains. And one thing we'll challenge you in this course to think about is, do course designers, do experts in an area, do the instructors that are creating our textbooks and our courses, do they really know what they know? They're actually good at doing things, they can perform well. But what we've seen over and over again, where we is not just me, but many researchers, is that what experts are aware of about what they know is just the tip of the iceberg. Actually, one thing you can reflect on is think of your first language. You know how to speak well in your first language and to use the grammar appropriately. And if you hear a grammatical sentence that is not grammatically well structured, it sounds funny. If I said, "It's funny," is a sentence, that doesn't sound right, right? You know that. But do you know what you know? Can you describe the grammar of your first language? Probably not. You've learned it mostly implicitly, tacitly. Well, this happens in all domains. And when we were building the Algebra Cognitive Tutor, we saw this when we collected data on which of these kinds of problems is most difficult for a beginning algebra student. I don't mean beginning out of the box. I mean a student who's had, say, about 6 or 7 months of algebra instruction. If you were here with me, I'd ask you to raise your hands to try this at home. Which of these 3 problems do you think is the most difficult for a student who's been, just beginning to learn algebra? Is the story problem the hardest, the word problem the hardest, or the equation? We asked this question of many math educators and did some formal surveys of them, and they not quite unanimously, but very consistently said that either the story problem or the word problem would be the hardest. Actually, when I designed this set of assessments, this study, I too thought that the story problem was going to be the hardest. But here's what the data actually came out to be, and we've done this a number of times and found the same results. Actually, the equations that are hardest for students. What this raises is the idea that the experts in this domain, the math teachers, educators, textbook writers, mathematics education researchers, they're good at these things, but they can't really reflect on what they know. They don't realize how hard it was for them to learn how to process equations like this, which are essentially kind of like a foreign language. And the results make sense if you think of this in that way. In other words, if you think of these as being communicated in your first language, let's say that's English, and this is a second language, let's say Greek, that you're learning, well, yeah, it's going to be harder to read a problem in Greek. An important part of this, by the way, is that students are able to solve these beginning algebra problems with methods other than using equations, obviously, otherwise this wouldn't make sense at all. And we do find that if we increase the complexity of problems, for example, by having the unknown referenced twice, the relationship flips around. The equations are worthwhile. But the key point, the general point here, is what we've sometimes referred to as expert blind spots. Experts do not know what they know. They are likely to incorrectly think equations are easy for students in this domain, but more generally, there's lots of great examples. And if you want to post a question on a discussion board about this, I can give you some other examples in other domains where experts don't know what they know. To summarize, this particular course is going to teach you about what to do in designing e-learning, principles for multimedia instructional, principles for designing good learning by doing, principles to support students in better learning skills, better metacognition, better motivation, better dispositions for learning. We'll also learn about when and how to do it, how to apply different design methods, cognitive task analysis, contextual inquiry, how to do good assessment design, how to bring user experience design, or sometimes called UX design, how to bring A/B testing to bear, and do that in the context of technology and analyzing real forms of instruction. I have a little more than 3 minutes left here in a 30-minute presentation. What I wanted to do finally here is give you a sense for some of the course electives and go back to the big goals of the Metals program. We have these 5 core courses. This is the e-learning design principles and methods is the one I just went over in some detail. Educational goals, instruction and assessment is another. Interaction design overview is a design-oriented course, so it'll give you experience in interaction design, building on graphic design, and other, basically some fine arts expertise in making things be better experiences for users and students. Tools for online learning is a technology course, and then of course this is a capstone project. Lots of super courses here at CMU. If you're coming from a computer science background or interested in learning more about advanced technology, there's lots of great courses. If you want to learn more deeply about the psychology of learning, lots of great courses. If you want to learn more about user experience design, yet again, lots of super courses. And we'll make these slides available to you. The list doesn't end here. There's many other relevant general electives across campus as well. And again, you can take a look at this list. What we're looking for in students is students who are really passionate about using technology to develop better learning outcomes, to develop better approaches that produce better learning outcomes. Your background can be in computer science, it can be in design, it can be in psychology, education, business. It could even be in an educational content domain like chemistry, for example. One of our first-year Metals students was a high school chemistry teacher, and she was a super student in this program and went off to work in one of our local startups and is having a big impact now. So we'll be selecting folks to be a good mix of these different backgrounds. If you have any questions about whether your background is appropriate, definitely send us email about this. We're wanting to provide you with skills to engineer and implement innovative and effective educational solutions. I'll unpack that in a second. You'll do real-world project-based experiences. You'll be involved in teams and team management and conflict resolution on teams. We'll teach you about. You'll learn about all of software development, psychology, design. But you're not going to, if you don't have a computer science background, don't expect to come in 1 year and be an expert in computer science or an expert in psychology. We will give you broad experience in all of those areas. We'll extend the depth of your experience in any one of these areas. And importantly, you'll learn to communicate with specialists across all of these areas. You'll learn to be a great learning engineer and learning designer. You'll learn to design, develop, and implement innovative, effective, desirable educational solutions. By innovative, what we mean is that you'll learn how to apply state-of-the-art technologies of the kinds listed here. By effective, we mean you'll learn about applying cognitive and social psychology principles to do better as instructional design, to analyze design, to do redesign to make courses better. You learn methods to design and evaluate, like the ones listed here. You'll also learn about making courses more desirable, and that goes to some of the courses in design, in educational games, and so forth, and about how to put it all together, and that's so important. You may already possess expertise in some of these areas, but probably not all of them, and Metals will both deepen your prior experience and broaden your knowledge in new areas. So lastly, from the nitty-gritties of finances here, the program is 3 semesters. Tuition is about $20,000 per semester. You'll need living expenses if you estimate that to be $20,000. That, of course, varies depending on you. But we're talking about something like an $80,000 commitment. The exact figures coming up for tuition are not set. But we are exploring the possibility of offering some merit-based tuition assistance, essentially some kind of scholarship program. So if you're really skilled and really passionate about this area, you want to come here, but the financial issues are a barrier, talk to us. Let us know, and we're going to try to figure out how to get the best students here to be a part of our program. So thank you very much, and if there are any questions, probably best if you type them in through the chat. We have you muted at the moment. Michael, do we have any questions?
We have 2 to start us off. So there's Karishma Gilani. I was wondering more about the rapid prototyping section that Ken was referring to. And then follow up, is there a specific design thinking model that the students use for, is there a specific design?
Yeah, well, let me just address that question as far as it goes. Rapid prototyping is something you will learn about and experience in multiple courses here. It is sort of in some sense, a fundamental part of engineering and designing products where you bring data to bear from the beginning through the middle and to the end. And the way you collect good data is by getting in front of a user or student something that approximates what you're trying to design, like this paper prototype. The details of particular strategies for doing that, I can't expand on a couple of moments here because they really are elaborated in many different ways. One version of that that's reflected in these storyboards is an approach of doing needs probes, where while these are kind of, these little cartoons are essentially some design ideas, the key notion of these early, they're not exactly prototypes, they're sort of weaker than that, but in some ways they're more powerful in trying to understand not so much whether this is going to be a usable product, but whether it's going to meet the needs and helping to discover what the real needs are of the customer base. So yeah, just to illustrate a couple of those procedures, but there really are systematic approaches for doing iterative prototyping and design.
Okay, next question is, can you point me towards any example,
any examples of?
How Carnegie used the cognitive model for software development outside of education.
Of how cognitive models have been used outside of education. I'm not sure what the questioner is getting at there, but certainly the idea of a cognitive model is broad and it overlaps with expert systems. So, if you have a computer-based cognitive model that can solve problems like human experts do, you can use it as a decision aid as part of the thinking process. So that goes outside of education. And certainly that's relevant, be addressed in some of the courses here. But the Metals program is definitely focused on applications of cognitive modeling, particularly for building better educational technologies. And part of what we'll focus on is that you don't have to implement a cognitive model, even though we did that in cognitive tutors, to use those strategies to be effective by thinking deeply about, this is kind of this point back here, that thinking deeply, forward here, about the domain content in understanding what it is that's really hard for students, not just what we intuitively think. Building a model of what's difficult, like comprehending these algebra equations. That model influences your instructional design, even if you don't implement it.
Is prior work experience required or preferred for this program?
Prior work experience is definitely not required. We really do like to get a few students who have had prior work experience, and in the first 2 years, we've always had some good proportion. I don't know, Michael, would you say maybe a quarter of our students have some? Yeah, I'm not sure. I think we look at your whole portfolio of experiences, your whole record when we're evaluating applications, and certainly. Some record of having done some relevant things helps your application. But that could be from course projects. It doesn't necessarily be from industry. And, and certainly just because you've had a job in industry isn't necessarily going to convince us. We'll want to see what have you done, what have you learned, what have you know, maybe what problems are you bringing that you want to answer because you understand industry more deeply. Yeah, let us know in your statement how your industry experience is relevant, but don't worry if you haven't had any. But tell us what you're passionate about, but also tell us what you're skilled in and what you've done.
Does the program provide any opportunity for practice? If so, what kind of practice does it provide? Course practicum?
Oh yeah, well, there's lots of opportunities to practice. So going back to these core courses, every one of them, including mine, has a project involved in it. So you'll be in the first semester doing projects in e-learning design, in educational goals, instruction, and assessment. Actually, I'm not sure if interaction design has a project, but there are lots of practical assignments. Tools for online learning has a technology implementation project. In all cases, depending on your background, the projects may put more emphasis. You may put more emphasis in your project if you have tech skills on technology development. If you have psychology skills or design skills, you might put more emphasis in your project on those. But already in the fall, you'll have a portfolio of practical educational technology design. But particularly starting in the spring with the capstone project, there you'll be working with a real industry client. You'll get a sense for what it's like to be in their company because you'll meet with them on a weekly basis. In some projects, you might even spend some of the days of the week on site with the company. So that capstone project is extremely practical, and that's the real focus there. We're going to learn by doing, and you're going to be working on a real project, not a made-up one. In these fall classes, you are often able to choose what the project's about. But in the capstone, as it is often in industry, perhaps with startups maybe being somewhat of an exception, you're going to have an organization, a boss that's guiding what the project will be about, and that'll be true in the capstone. But a lot of practical experience, and a lot of that will be team-based.
How many students in your program currently receive financial support, and where are the most common sources of financial support?
We have not in the first 2 years provided any financial support directly from the program, although as I said, we're considering that going forward. Individual students can seek various forms of support like loans. And Michael, do you know more details about our past students? How many of them have had loans?
Most of the students, almost not all. There are some who were supported by family and some who were self-sufficient, who were able to pay for this on their own. But most students do get some sort of loan. There's a link on the website that shows financial aid that's available. There are loans available for U.S. citizens. Unfortunately, it is limited for foreign national students.
Well, the U.S. Loan programs are limited, but your own countries may have loan programs. And yeah, send Michael questions if you have them on these issues, both because we can point you to these loan opportunities that we're aware of. And by the way, if anybody out there knows of loan programs available in other countries, we would love to point other students in those countries to them. And if you're a great fit for our program and really want to come here, and money's an issue, let us know. We are wanting to work with and figure out how to make it all happen. So please send us an email with questions on that.
Do many of the graduates of the program end up getting hired by the capstone partners?
Well, the capstone partners are definitely doing this in part to probe whether there are folks that they may want to hire, and they have always expressed interest in that. We've had 3 clients for 4 projects, so we've had 1 repeat client. As a matter of fact, none of those 3 clients have yet hired any of our students. But all of our students are getting great in multiple job offers. Most that just finished, have offers. Some are still deciding among multiple offers. But some of the folks that have been hired from our program have gone to companies that are a part of our corporate partners. So our network of contacts has definitely been helpful for them in terms of landing jobs. But we have people at companies, big companies like Pearson. We have people at startups like XP and Carnegie. Well, Carnegie Learning is no longer a startup, but I guess it has about 100+ employees and it has employed one of our graduating students. Some of our students, we want to foster the educational technology industry here. Some of our students have found user experience jobs that are broader than educational technology. And again, that depends on your particular background and where you might go.
So here's one maybe for me to answer. Michael, how will Medal help students who are interested in working in the U.S. find jobs? I mean, after graduating from the program, are the odds of getting a job in the United States high? So we have let me walk around to the microphone. So the Medals program is part of a STEM program that the United States offers. It's when you graduate, foreign nationals are allowed to work in the United States for 12 months. With the STEM program, there's a 17-month extension on top of that, so that as of now, that would be 29 months that you're allowed to work in the United States before you would need to find another means of sponsorship. It's not, and there's also, if you work at universities or nonprofit organizations, there's something called a J-1 visa, where you can work, I believe it's currently up to 5 years on a J-1 visa. As far as helping you find positions, I have a list of several thousand individuals that I send email out to, work with you to recruit. I work with you on getting your resume up to snuff. I remind you that you need to have a portfolio, and I help you get your portfolio up. That's a web-based portfolio that you can showcase to your potential employers. And there's still pretty much everyone's employed. I think there are a couple people still from last year that I'm still working with. We graduated in August, but we typically are getting, if not 100% employment, near 100%.
They will all.
Yes.
Yes. Be employed very soon, we're confident.
Yeah.
There's just a few that are negotiating over positions. One thing I want to add to that is there is a way to get a permanent, essentially, work visa, and I've done that with past foreign PhD students of mine. It is a reasonably intense process, but to qualify for that, you have to argue that you really have unique and special skills. And I think if you come to Carnegie Mellon, that's what we're intending to give you, is unique and special skills. So you have a good shot at being able to get one of those permanent visas that go beyond that. What did you say, Michael? 29 months?
Yeah.
Essentially? Yeah.
So here's the follow-up question that I think a lot of people want to know the answer to. What is the minimum GRE score for the program, or the average GRE scores from the accepted student? That wasn't on the slide anymore.
We definitely have some guidelines that we use there, certainly not hard and fast, but we are looking for students who, we can get some sense that they have strong quantitative backgrounds, that they can communicate well in writing. That's an important part of the program and what we want to see in professionals. So we look at those scores closely. If you're below the 50th percentile in quantitative, that probably is not going to work. We're usually looking at students who are at least 75% or above in quantitative. It is, it's somewhat, in the School of Computer Science, it is somewhat more of a quantitative program. If you have design or psychology experience, you want to have a technical angle somewhat as well. If you have super good GRE scores in the other areas, that can compensate. But if you're even in the other areas, if you're below 50 percentile, that probably is not going to work for us. We look at your grade point average as well, and again, if that's really high and your scores are lower, that can help compensate. If your grades are lower but your scores are really high, that can work too. Obviously we're trying to pick from the best candidates out there. We look closely at your research statement and we look at your recommendations, and we look for recommendations that that give a really clear and deep sense that they know you and they know what you've been able to do. We look at your portfolio, if you have a portfolio of some kind, particularly if you're coming from the design side of things, or if you've developed any technology, if you've created apps. We look at those, so include those in your application because they can demonstrate skills that you may have that aren't reflected in your test scores or your grades. I guess as long as we're talking about test scores, we do have pretty strict minimums on TOEFL scores. So if you're not a native English speaker, you want to have a TOEFL total score of at least 100. We want to see that your speaking score is over 25. I think we hardly ever make exceptions on those two things, and those are minimums. We might ask you if we're concerned about your language abilities, to send us a video, a short video of you speaking on some potentially relevant topic. But that's not going to compensate for a really low TOEFL score. So plan ahead on these things. If you can retake these tests and want to raise your score, of course you have to be practicing in between to do so. But do that and make your scores better. And if they're good and your profile across the board is strong, then we'll look at your application very closely.
Is it possible for me to visit campus, sit in on class, meet current students, and talk to a professor whose research overlaps my own?
Definitely.
Now, before open house or before?
Well, I think you can come visit, and students, where the Metals have a big office, the Metal students have a big office area. Michael can bring you over there and introduce you to students. Faculty will, if you come, their schedules are often pretty busy, but if you do it far enough ahead of time, if you let us know when you're thinking of coming far enough ahead of time, we can arrange meetings, short meetings with faculty. And as the questioner said, if they have a particular area of educational technology or learning science research that a faculty member, matches very well, then, send that faculty member an email and tell them about your interest and engage them, because that's a good way, too, for us to get to know you better if you can make a substantive connection with a faculty member because of a passion you have for a particular issue, and also, demonstrate that you have some good understanding for that issue in your email, that goes a long way. And yes, come visit us. There will be a face-to-face open house as well, and that's the best opportunity because that'll be more organized. We don't have a date published on that yet. Yeah, but that will come out.
Actually, it was March.
In March, we'll have an open house, and it'll be, if it's not on the website already, it will be on the website. But yeah, I know sometimes people are traveling through at different times. Just ask us ahead of time so we can do our best to accommodate you.
What programming experience is required? Any specific languages, Java, Python, etc.?
Java, Jest?
Java, Jest.
Oh, yeah. Well, Jest is super, but we don't require any particular programming language. Courses will use Python or Java, but we'll also be, for those of you who don't have much programming experience, we do, like in my course, I have students build an online assessment using tools that are out there that allow non-programmers to create online assessments. So, we'll be emphasizing use of tools that allow non-programmers to build. But, we're also interested in... Yeah, Michael's making sure I don't forget. I was going to say that. We do require some programming experience, and we do also provide, though, if you haven't had any, a summer, the summer before you arrive here in the fall, there's a placement course that you can take and graduate to satisfy that programming requirement ahead of time. If you have programming skills, we're looking for students who are great developers to be a part of the program. So, yeah, those languages are great. JavaScript, HTML5. There's, sort of multi-paradigm programming is increasingly becoming important. So, especially if you're linking your code into websites or mobile devices, or doing data linkage on the back end, being able to flexibly move from one language to another is really important. Being able to use tools, including rapid prototyping tools, is part of what we'll teach you.
Okay, let's see. There are a few questions I was able to answer. I think I got everyone's questions answered.
If you don't think your question has been answered, type quickly into the chat so Michael can find it if he hasn't. If I haven't answered it already.
Here's a new one. Do I need to submit recommendation letters for my application?
Recommendation letters are required. We require 3 recommendation letters as part of your application.
Oh, could you elaborate on the lab facilities?
Well, our faculty all have labs. There are, as I said earlier, with respect to where you do your work, we have a really nice space for the metal students that has a lot of whiteboard space, has a lot of, part of the design processes you'll learn about is affinity diagrams, putting up Post-its and organizing ideas from your qualitative interview research. So that space is great. That space has also been designed to be kind of fun. There's a foosball table there and other things so you can relax a little bit in the heat of things. But yeah, with respect to research labs, those are associated more with individual faculty. And you can, I didn't say this about electives, but you can do special topic courses and get involved with individual research labs, and many students have done that. I was going back to this image, if you can see it. Scott Hudson and I supervised a PhD student, Nezra Yanir. If you want to see more about her shake application, which here is a Kinect camera that's watching this kid do experiments on this earthquake table. You probably can't see that. But in any case, Scott Hudson has this lab that has all kinds of hardware capabilities. There's a 3D printer there. They do a lot of ubiquitous computing, building out sensor hardware, using like Kinect cameras and other things to do really innovative, human, is it computer anymore, but human technology interaction in really novel ways. And you can learn about that in courses and, again, by doing independent studies in individual researchers' labs. We have an eye tracking machine in Vincent Alavin's lab. Of course, on campus, the Metals program doesn't get much into brain imaging, but there are labs that have fMRI scanners on campus and that sort of thing. I hope I touched what you were asking about in your question.
Here's a softball. Are you doing research on adaptive learning systems like Newton?
Well, Newton, as I heard from a Slate reporter yesterday, has, I think, been correctly characterized as reinventing the wheel. Yeah, we've been doing intelligent tutoring systems, which are forms of adaptive instruction, since the 1980s. And in the early 1990s, when we were doing the research and development that led to the cognitive tutors, which are highly adaptive systems, we were already starting to get into schools in the early 90s. Actually, it was one of those projects I also taught high school geometry for a while. Very eye-opening experience here in a city school. But yeah, the cognitive tutors are adaptive, as I was telling the Slate reporter yesterday, in at least 3 important ways, in ways that most technologies at best hit 2 of these. The one form of adaptation is in the design process is data used to adapt the solution to the student population as a whole. And what we'll teach you about is how often, because experts don't know what they know, you can use data to discover things about what's hard to learn in the domain that even the experts didn't know was hard to learn, and the instructional designers didn't know it was hard to learn. When you make those discoveries, you are already adapting based on data, your technology design, to be better. And that's design loop adaptation. You can do sort of problem selection adaptation. Recommender systems is one sort of hot way to do that now, but we've used Bayesian inference techniques in the cognitive tutors to select the problem that best is going to help students practice and improve their understanding of whatever topic or skill they're currently struggling with. And then the last one that a lot of technologies are missing these days is in the process of working on a bigger open-ended problem, the steps you're working on, if you go in a different direction than another student, can the system adapt to different student strategies and different kinds of errors? And the cognitive tutors can adapt at that level too. So yeah, I think we could say without at risk, I guess, of bragging, that this is the place that's made adaptive technologies work out in real context. The open learning courses are another form of adaptive system that's out there. And we use data mining to improve our systems. I know Newton talks a lot about doing it, but I really actually haven't seen. They say a lot about what they're going to do, but they don't actually say a lot about what they've done. So I like what they say they're going to do, and I hope they're doing it. But I do think there's lots of other products, not just ours, but Alex is another one that's out there in the marketplace. And they've been out there since the 90s. You're also seeing, in a slowly but surely, more adaptive systems being used in the context of MOOCs, and including language-based systems. Carolyn Rose on our faculty here is probably the world's leading expert in dialogue-based tutoring systems. Perhaps some folks at Memphis would argue about that, because they've got some really good language technology-based adaptive tutoring systems. But certainly they'd agree that she is among the top leaders in that area. So yes, lots of forms of that adaptivity. Yeah, including in this Connect camera thing I was showing earlier is adapting to whether the child's prediction about which tower on the earthquake table is going to fall to give them an appropriate response, because it actually sees which tower falls and can adapt in that way through AI vision technology.
Okay.
That was long, huh?
This is an important one. If applications are due December 15th, does this include GRE scores? If not, when is the latest GRE scores should be received?
Yeah. Well, yeah, we really want them by the 15th, but yeah, the practical issue is when we get together to review applications. That's really the drop dead deadline for that. And around mid-January is close to when that'll be. We actually haven't scheduled the review meeting, but that really is the drop dead deadline. If you don't have those scores into us by the end of January, well, actually one caveat on all this is that we are open to some possibility for some rolling admissions. So if you miss those deadlines, you know, I know that scheduling tests has to be done ahead of time, and if you know you're going to miss that deadline, let us know ahead of time, and we'll give you some feedback as to whether we'll be able to move forward and on what time scale with you. Anything else?
So I'm not sure, this one doesn't have contact, so I'm not sure if this is in regards to the medals program or the applications or what. Do you value research?
Do we value research? Oh my God, yes.
Well, maybe previous experience.
Oh, do we value? Yeah. So when do we value a student's previous experience with research? Yeah, definitely. And that could be, there's research of all kinds. There's more psychology-oriented research we value. We value technology-oriented research, design, even sort of, you know, there's parts of your experience design and HCI that are oriented towards what you might call anthropology kind of research or ethnographic research. We value that too. So yeah, if you've had research experience, we definitely value that. This is a professional program though, so we're looking for people who want to bring research to bear on real problems and solving real problems and creating better products and better processes.
And I think that is it.
That's it. Great. Well, so glad you all came and apply for the program. Send us your questions, and we look forward to seeing you. So thanks again.